how's it going, everybody? This is a video I wanted to make for a while, but I had to graduate college first. I just want to go and talk about what were the most useful courses for me during my entire degree. So people who are going to college now or currently in college can maybe plan a little bit better or like pay attention to certain classes a little bit better. I have a few notes down here because I want to hit all my talking points. So if you see me looking down here, I'm just hitting some talking points to make sure I cover everything for you guys. So there's a few things I want to preface with. If you don't want to listen to any of this preface, you can just skip. I'll leave some timestamps in the description. You can check that out. There's no shame. But yeah, let's get started. So first is that computer science can seem like really broad. So it's kind of a tough question to answer this. But just keep in mind that this is for a generalist software engineer for like internships or a new grad position. Second, the titles can vary a lot. So something that might be called like discrete structures at Rutgers might be called discrete math at another school. So look less at the titles and more at the context of the contents of the courses. And I'll leave descriptions to like the syllabus of these courses in the description. Third, teachers can really make a big difference, but I want to focus not on the quality of teaching, but rather just the contents of courses that have been very helpful. And then fourth, we're not going to count Intro to Computer Science, even though it is obviously one of the most important courses for a good foundation. Okay, so number one is data structures, which if you've taken data structures, this is no surprise, I'm sure. It comes up in pretty much any problem you solve. You have to implement some sort of data structure, at least in interviews. If you haven't taken the course yet, you can kind of familiarize yourself with what I'm talking about. I'll leave links. Some data structures include an array, which you've probably learned if you've done some basic computer science, but there's a lot more than just arrays, trees, linked lists, heaps. So why is it useful? One is, as I said, almost every interview question will have you implement some sort of data structure. Secondly, it's kind of a creative area because there's always a lot of solutions to a single problem. So the way you do your solution in an interview can really separate you from the rest or keep you average, mainly because of efficiency. And that's the third talking point, is that in this class, you really dive into efficiency of algorithms, efficiency of the data structures themselves. So to get good at this is like a really good skill because it doesn't go away. Fourth, you learn graphs. For internships and even like new grad positions, it's rare to see graph questions. It's one of those things where it just sets the bar really high for what you're capable of. And obviously when you do that, everything below the bar gets a little bit easier. So if you get good at graphs, hopefully trees seem a little bit easier to manage. And then fifth, the last point is that this class has a lot of recursion in it. And if you don't know what recursion is, that's okay. But it's one of those skills that once again doesn't seem to leave when you're in a computer science major. And it's if you have a good understanding of recursion and you can implement recursive algorithms, I think that's what really separates like a good programmer from a great one. So you can't really cheap out on that. Final thoughts. So people who use like LeetCode and HackerRank for interview prep, mostly they're almost always just practicing using their data structure skills essentially. And if you haven't taken the course yet, don't worry about it. But I would just say don't cheat your way through it. Don't look up code. Don't copy your neighbor's work. It really just doesn't go away, that class, and it's just not worth it. It's better for you to completely understand what you're doing. Okay, number two is software methodology, which is like the vaguest name ever, so thank you, Rutgers, for that. I don't know if it will translate to your courses, but I'll talk about specifically the topics, and I'll leave the syllabus in the description. Essentially, software methodology for Rutgers is like picking the primary language that we use, which is Java. At other schools, it might be Python or C, and then diving deep down into that language, past the basics, into like things like inheritance, abstract classes, polymorphism, streams, like really specific stuff of a language. It's basically specializing in a language and doing it constantly with many projects. I ended up taking the class really late. I think it's usually a sophomore, junior level class. And I took it my senior year. And what happened was I would go on an interview and I would get a question and I wouldn't know how to do it. And then the next week I would learn it in lecture in this class. And I was always so pissed. So I felt like I was 1 week behind. So I asked my professor, I'm like, dude, like I need to like know everything that's taught in this course ASAP, because it seems like every interview I go to is asking things about abstract classes and inheritance. And I always felt like I was behind. I should have taken that earlier. Why it's useful, I kind of covered one, which is just learning, specializing in a language, like deep down. I think it's kind of cool to be a generalist, but at the same time, once you go deep down into a language, you start to see patterns that reveal themselves in other languages down the road when you learn new things. So definitely a good translatable skill. Second, this is the class where we did just a ton of projects, like 5 or 6 for a semester. There's some classes where you might do just one project the whole semester, but doing 5 or 6 really helped engrave, everything they were trying to teach, and just getting good at pushing out projects fairly quickly. These projects were usually with partners. I don't know if all schools tend to do that, but Rutgers did. And I think that's also good because we all know how kind of like bullshit group work is at university, but at the same time, if you can look past the BS and actually kind of take it seriously and divide up work and not step on the toes of your partners, I think that is a really good skill to have. Because for me, I feel like a lot of computer science people might be a little kind of like control freaks, that they need to know everything about what's going on. And to have that trust that your partner's going to deliver on something that you might not even know what he's doing, but you trust that he's going to deliver, I think it's kind of a really good skill to have trust in other people. And lastly, with that, you're doing Git a lot, which is a version control system. If you haven't used it, never goes away. Totally want that skill. So not bad at all to have. And then third, for why it's useful, is you learn UML, which is called Unified Modeling Language. That's what that stands for. It's essentially a way of breaking down projects and drawing them out into little modular components. So if you do have partners, you can split up work, but also just to see everything that you're going to build before you do it, and really just pre-planning and getting good at that. Because if you can find mistakes in your plan, you can save yourself a lot of time down the road. Usually if you walk into an office, you'll see, a whiteboard with a bunch of boxes and lines connecting everything. That's usually some form of UML. Okay, number 3 is the design and analysis of algorithms. Other schools might just call it algorithms, or algo for short, some people say. This class kind of felt like data structures on steroids. It's one of those classes where everything was not like directly useful, but it really pushed you every day. It felt kind of more like research, but it really got my mind thinking in a really nice computer science type of way. Why it's useful? First is you're categorizing a lot of problems a little differently in the class. I think they categorize like NP and P problems, so don't worry if you don't know what that is, but getting in the habit of doing that, I think the benefit is your mind really improves at just analyzing algorithms and analyzing problems when you hit one. So you get really consistent at it because you're thrown a random problem, you categorize it, and then you attempt to do it with that knowledge of how you categorized it. And that's essentially what an interview is. You're going to get asked a random question, you have to kind of categorize it and then go at it. You don't really have too much time to screw up. Secondly, you learn dynamic programming. That's very similar to like what I said about graphs and data structures. You might not be asked too many questions on dynamic programming, but it's one of those things that just raises your bar. And when you do that, everything underneath it becomes a little bit more simpler, understandable, and easy. Number 3, a lot more recursion. I think like data structures, you can kind of get away with just not fully understanding recursion or not being the best at it. For algorithms, it was like you had to be good at it in order to actually pass the class. So that really helped me practice recursion, and in interviews, you're usually always asked some recursive question. And then 4, you learn what's called divide and conquer, which is more of like an ideology for a lot of different algorithms. And knowing that very well is kind of an abstract idea, I think is really helpful, because I know in a lot of interviews I've been asked about some form of divide and conquer algorithm. So as you probably noticed, for algorithms, it's a lot of stuff that's not directly useful, as you would think, but it's the class that really got my mind thinking in the right direction. And I think just after taking that class, I automatically was better at solving problems. And to be honest, like that's a lot of the computer science major. They can't, like I said before, it's such a broad major that if they taught such specific knowledge, it wouldn't be so useful. But the stuff they teach seems to be very helpful in how your mind thinks and how your mind approaches problems. And that's the whole point. Like there's no rule book for what problems are going to come your way. So getting good at that is really helpful. And I think that class was the one to do it for me. Okay, so what do all these have in common? The 3 that I mentioned, which was data structures, software methodology, and algorithms. I think they're all very fast-paced, iterative, with a lot of projects. Some classes, like I said, you might do a project the whole semester, and that's kind of cool, or you might just do a lot of abstract knowledge in a lecture the whole semester. But classes where you're doing a lot of problem solving and very quickly, that's the type of skills you need for interviews. I'm not saying it might be the skills you need on the job, but those are the skills that you need for interviewing. Just very quick, iterative problems that you're solving very quickly, building out programs constantly, working with partners, working with Git, because you have a lot to say on those things when an interviewer asks you, what projects have you done? So really fast-paced classes that do a lot of projects, I think, end up being the most helpful. Secondly, a lot of these classes make me realize that a lot of these abstractions and a lot of these paradigms in computer science, these data structures, etc., they're all just made up. They're made up abstractions. So computer science at a fundamental level is very specific. But once we have these building blocks, we can build all these abstract things, like building a table. You can build a million different tables out of wood. So once I realized that all this was kind of just made up, it gave me the confidence to go in and really just learn anything. Because if everything's just made up by us people, then surely we can all kind of learn it. So that gave me a lot of confidence. One bonus class I won't go too much into, but I'll try to leave links about it, is discrete math. We had discrete math 1 and discrete math 2. I think just knowing probability theory, although I very rarely used it in actual code, is just like algorithms where it got my mind thinking so well. And I had a terrible teacher too, so it's a lot to say for a class with a terrible teacher. Discrete math, you'll definitely take it. The semester after I took it, my brain just felt like I could process problems a lot easier for some reason. It was another one of those really fast, iterative classes. So in conclusion, there might have been some surprises, there might not have been. If there wasn't any surprises for you, then that's just, it's kind of how life is sometimes. You just got to sit down and do it. I wish you guys all the best of luck in your courses or your choices. The only elective in here was software methodology. The other two are required, so you'll probably find them in your curriculum as well. If you want to get started on them, check the description. And yeah, that's it. Have a wonderful day. Let me know if you have any questions, and I'll see you in the next video.